In previous lecture, we have studied concept of Heimborel property, Heimborel definition of compactness. That is, a metric space XD is said to be compact if every open covering of X possesses finite subcover, which is nothing but Heimborel property. Now, in this lecture, we will study Bolzano-Weierstrass property, sequential compactness related with regarding with metric spaces. So Bolzano-Weierstrass property for R, what is BWP, Bolzano-Weierstrass property for set of real numbers. So if S is any non-empty closed and bounded subset, if S is non-empty closed and bounded subset of R, closed and bounded subset of R, then any infinite subset A of S, any infinite subset A of S has a limit point, This is nothing but Bolzano-Weierstrass property of R. Now Bolzano-Weierstrass property for metric space. In general, this result is not true. A metric space XD is said to have a metric space XD is said to have Bolzano-Weierstrass property, Bolzano-Weierstrass property, Weierstrass property if any infinite subset E, if any infinite subset A of X has limit point, has a limit point, has at least one limit point. This is Bolzano-Weierstrass property of metric space. Example, if I take, consider X is equal to open interval 0, 1, open close interval 0, 1. Be metric space with respect to usual metric, then A is equal to 1 half 1 by 3 and so on. Is infinite subset of XD is infinite subset of X having limit point having no limit point, then A is infinite subset of X is such that A has no limit point, as 0 belongs to R is only limit point of A Limit means here accumulation point, limit point of A which is not in S, which is not in X, not in X, and therefore X is equal to 0, 1, open close interval 0, 1, doesn't possess or doesn't have Bolzano-Weierstrass property. Now we'll see definition of sequential compactness. Sequential compactness. A metric space XD is said to be sequentially compact if every sequence in X has convergent subsequence. A metric space XD is sequentially compact if every sequence of points in X has a convergent subsequence. Then we will say that metric space is sequentially compact. Moreover, a subset Y of metric space XD is sequentially compact if YD itself is sequentially compact. Okay. Now we'll take the relation between sequential compactness and Bolzano-Weierstrass property. Okay. So theorem. A metric space XD is sequentially compact if and only X have Bolzano-Weierstrass property. So firstly, suppose XD is sequentially compact metric space. Suppose XD is sequentially compact. What is our aim? XD has Bolzano-Weierstrass property. So let A be infinite subset of X. Means what we have to show, any infinite subset of X has a limit point. Okay. So let A be infinite subset of X. We'll take A to be infinite subset of X. Take sequence xn of distinct points from E. As A is infinite subset, so I can take the sequence xn of distinct points from A. Now since by hypothesis. Okay. Since X is sequentially compact from A, then Xn is sequence of points in X. Therefore, by hypothesis, Xn has convergent subsequence. Has convergent subsequence, say Xnk. Say Xnk. Suppose limit of Xnk is equal to X. Suppose limit n tends to infinity, Xnk is equal to X, belonging to X. Then for any epsilon greater than 0, for given epsilon greater than 0, there exists positive integer n naught such that d of Xnkx is less than epsilon for every nk greater or equal n naught, which implies Xnk belongs to S epsilon x. S epsilon x. Intersection A, and therefore S epsilon x for every nk greater or equal n naught, and therefore S epsilon x minus singleton x intersection A, this must be non-empty set for any epsilon greater than 0. What this implies is x is the limit point of X is the limit point of A. Thus, every infinite subset A of x has a limit point, and therefore xd has Bolzano-Weierstrass property. Now conversely, we'll assume that suppose xd has Bolzano-Weierstrass property. What is your aim? xd is sequentially compact. So let xn be sequence of points in A, points in X. Let A is equal to range of Xn case 1, if A is finite, A is finite set, then there exists at least one action then at least one action of sequence action repeat infinitely many times. Infinitely many times. At least one xk of sequence action repeat infinitely many times. In this case, if I take that sequence xk, 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 it is convergent subsequence of xn. In this case, xk, xk, xk is convergent subsequence of xn. Case 2, if A is infinite set. Case 2, if A is infinite set, and X has Bolzano-Weierstrass property, and X has Bolzano-Weierstrass property, implies A has a limit point, A has a limit point, say x belongs to x. Now in this case, then S1x contain infinitely many points of A. Choose list n1 such that xn1 belongs to S1x. Again, S half x contain infinitely many points of A. Infinitely many points of A. Choose list n2 greater than n1 such that xn2 belongs to S half x. Continuing thus, we get subsequence xnk of xn such that d of xn yes d of xn k x must be less than 1 by k, which approaches towards 0 as k tends to infinity. And therefore, xn has convergent subsequence. Xn has convergent subsequence action key. Thus, every sequence of X has convergent subsequence. Thus, every sequence of X has convergent subsequence. Therefore, XD is sequentially compact. So thus, in this lecture, we proved that a metric space is sequentially compact if and only if it has Bolzano-Weierstrass property. So with this discussion, we'll stop our lecture here. Thanks for listening lecture carefully. Bye bye.